So, in the last class of introduction, we discussed about what is strength of materials and why it is useful, where it is useful. But now we discuss about what is the main aim of strength of materials and what are the assumptions we should consider before we are dealing with the strength of materials. That is what very important. So, main aim of the strength of materials is to find the relationship between stress and strain. Okay. So, what is this stress? What is this strain? So, the stress is nothing but the resistance which is developed in a deformable body to the load which is acted upon it. That means, whenever you are applying a load, for example, on this sponge, we are applying load, right? We are placing this marker. So, it is resisting. Right, it is resisting the failure. That means it is not bending like this or it is not crushing like this. So the reason why this marker is staying on this sponge is the stress which is developed to resist the failure or to make it stable is nothing but stress. The stress is nothing but resistance which is offered to the body, to the load which is acted upon a body. So this main aim of the strength of materials is to find this stress and the strain relationship. So that means the strain. So in case of strain, what is strain is? Here strain is nothing but delta L by L. That means change in length by original length. If this load is acted in this direction, okay, so it will crush a bit. So it is expanding a bit, right? So this expansion will cause some deformation, right? For suppose that is 0.1, the main length of this sponge is, for suppose, 1 centimeter. For example, just for example, the sponge is 1 centimeter. And due to this tensile load, when load acting away from the body, it is called as tensile load. When load is acting towards the body, that will be considered as compressive load. Okay, so all these things we will discuss in stress and strain in the next chapter. So we are discussing brief introduction, right? So here, for time being, it is 0.1 centimeter, right? So sorry, the strain has no units. For suppose it is 0.1. Okay, because there is no units because it is centimeters, right? So there is an expansion of 0.1 centimeter in this delta L, in the total L, and this is delta L. So there will be a relationship as the load increases, the strain is increasing. That means stress is directly proportional to strain. But if the stress is inversely proportional to strain, then the relation will be different. So it will be dependent upon what is we considering. So the mostly to figure out this relationship, is it directly proportional or indirectly proportional, and how the relationship is varying as the load increases, that is how the stress is varying, whether it is increasing or decreasing, and how the strain is varying. As the stress increases, the strain is also increasing or not. So this relations, to figure out this relationship, we need to study strength of materials. How the load making the body to deflect or deform or to expand or to contract, what it is making the body, what type of strain it is creating. Strain is nothing but the expansion or contraction of a body. For timing, you should understand as this. So what is the stress? Stress is nothing but the resistance which is offering by the body. It is nothing but load by area. So load by area. This is the load, this is the area. So right. So how much load is acting, how much the area. So how the stress and strain relationship is varying. This is the main thing that we are considering. This is the main aim to study the strength of materials. Here only one load acting. But if the number of loads acting, number of points of application of load is increasing, we need to learn about more complex things. So That's why we are reading complex stresses and how the load that is acting on the body is making deformations and how the deformations are changing. So all the things we will discuss in the strength of materials. So the main aim of the strength of materials is to find the relationship between the stress and strain in a body and the angle of obliquity. Angle of obliquity means angle of obliquity. It is the angle between the normal stress and the resultant stress. So we will discuss it clearly in complex stresses. Okay. So this is the main aim. The main aim is to find the relationship between stress and strain and to find the angle of obliquity. So to know this relationship, we are considering some assumptions because all the subjects, whatever may be the subjects in engineering, we need to consider some assumptions before we are designing something or before we are analyzing something, because there are ideal conditions. For ideal conditions we are only discussing because we cannot determine every aspect. So for that we are idealizing some of the assumptions. So in this we are assuming that stress and the strain is proportional up to the proportional, is directly proportional up to the proportional limit. So that is Hooke's law is valid. In stress and strain we will learn Hooke's law. Hooke's law states that stress is directly proportional to strain up to proportional limit. So when we draw a graph to the stress and strain, as for the first assumption in strength of materials, we are saying as the stress increases by 1 unit, the strain is also increasing in 1 unit. As the stress increases by 2 units, the strain is also increasing. That means linearly elastic. The relationship between stress and strain is linear. Here we are saying as stress increases, in the same portion strain is also increasing. That is what we are considering. And the stress is directly proportional to strain up to the proportional limit. That means in elastic curve we will know here is elastic limit. So up to here stress is directly proportional to strain in some proportion. If the stress is 1 unit, the strain is also increasing in 1 unit. So this is what the linear relationship means. So we are assuming that stress is directly proportional to strain. That means if the stress is increased by 1 unit, the strain is also increasing by 1 unit. So next we are considering the self weight is neglected because different materials has different self weights due to their densities are different. So if we are assuming a body, if you are analyzing a body, we are assuming that the self weight of this body is not considerable, and after that we are considering the material is homogeneous isotropic. So in many conditions, in many situations, we are considering in strength of materials, whatever may be the analysis, we are considering it is as homogeneous and isotropic. So what is the homogeneous and what is the isotropic means? So homogeneous means if I am analyzing this material, if I consider any point in that direction, the material will be same. That means the properties of the material is same. That means in a point in one direction. And here we are considering one point in that one point in one direction. If the materials are same, that means if I can consider wood in this direction also, in this horizontal direction also, there will be another wood as the material goes up. Here I am considering a sponge. Here it is sponge. As we go in this direction also, it should be sponge. It should not be other material. That means no composite materials. There will be no composite materials. So only one material should be present. And another condition is isotropic means if I consider a point and in any direction, this is one point, one direction, in any point, in any direction also, the material should be same. If I consider this, if I go up, if I go down, if I go left, if I go right, whatever may be the direction, it should be the same material, the same properties, that is isotropic. So in strength of materials, so the material, for assuming a material, what should be the assumption? The material should be homogeneous, material should be isotropic. If it is homogeneous, the material in a point in a one direction, it is if it has the same properties, it is homogeneous. If it has same type of properties in any direction, it is called isotropic. At the same time, a material can be homogeneous and a material can be isotropic. No composite material is a homogeneous, but here composite material can be isotropic, but no layered material is isotropic. So these are the material consideration. Here sulfite is neglected. So as we discussed, and for this, the superposition principle is valid. Another assumption is superposition principle is valid. So what is the superposition principle? If I have multiple loads, on the body, they are causing some deflection. So look at this point, they are causing some deflection, right? So there are number of loads. I think I had three fingers, another three fingers on this hand. So they are acting on this body. So I consider these fingers load. There are another three fingers on here. Okay, they are acting on the body. So here the individual efforts of individual loads acting on a body is equal to total effort. That means my finger 1 is delta 1, my finger 2 is delta 2. That means loads causing some deflections. This is delta 1, this is delta 2, this is delta 3. That means delta means deflection. Due to load 1, it is causing some deflection, delta 1. Due to load 2, it is causing some other deflection, delta 2. Due to load 3, it is causing another deflection, delta 3. But this individual, all the deflection are equal to delta. That means the deflections caused by the delta 1, delta 2, delta 3 is considered to be equal. Right? So here we are considering delta 1, delta 2, delta 3 is equal to delta. That means the superimposed. That means delta 1, delta 2, delta 3 efforts are equal to the total delta. This is another thing. That means why we are considering this assumption means we need not to the individual efforts every time. It will be lengthy. So that's why we are considering the different loads which are causing the deflection is equal to the total deflection. So if it is not valid, then the material will become indeterminate. So delta 1 plus delta 2 plus delta 3 equal to delta. This is superposition principle. So the name itself indicates superposition. That means one another. So if the number of loads acting in a plane, the individual efforts created by a body, created in body is equal to the total effort. That is superposition principle. Next, Saint-Venant principle. Saint-Venant principle is another assumption. What is the Saint-Venant principle is? So Saint-Venant principle says that if a load is acting on a plane at a point or a beam, so the load deformation will be this way. But as per the Saint-Venant, we are considering what is the maximum load here we have is the same throughout the section, throughout the length of the beam. That means if this is the point of application of load, here the intensity will be more, load intensity, but we are considering it as uniform because it is hard to analyze every part of the beam. So because as the load intensity changes from point to point, we need to design it separately. But if we assume it as uniform for the maximum, here what is the maximum here? That will be considered to the whole. That means for a beam, the maximum load will be at the middle, but this maximum load will be used for whole design. So it increases the safety also. So that's why Saint-Venant principle and superposition principle. So we are considering this assumptions in strength of materials. Okay. So now let us revise the whole class which we discussed. So what is the main aim of strength of materials? It is to find the relationship between stress and strain. How the stress and strain is varying. Say at which stress the maximum strain is developed in the body. So that is what the main aim. So the relationship we are finding here. And what is the angle of obliquity? Angle of obliquity means what is the normal stress and the resistance, what is the angle between the normal stress and the resultant stress, and what are the assumptions that we are making is the stress and strain is linear and the total deformation is equal to the individual deformations. In another way, the total effort is equal to the sum of all individual efforts. This is superposition principle. What is the same unit principle? If the load is acting at a point, the distribution will be different. That is, it may be parabolic, but we are considering it as uniform for the convenience of designing, and we are considering the material self-weight is regulated, and we are not considering the self-weight, and we are considering the material as homogeneous and isotropic and linearly elastic. Okay, so what is the elasticity? At the end, we need to discuss about what is elasticity. Elasticity means if the material can regain its original shape after removal of the load, it is called elasticity. So, for suppose a rubber is stretched and left out and left after, so it will come back to its original position. That is called elasticity. Steel is also the same elastic. It is more elastic than rubber. So, we will discuss in the further chapter, that is stress and strain. So, in the properties of materials, this is what we are discussed about the assumptions and the relationship of what is the main aim of the strength of materials.